Let's try to simplify the given expression. We'll state the De Moivre's theorem first. That theorem states that whenever we have cosine of theta plus iota times sine of theta raised to the power of n, then this will be equivalent to cosine of n theta plus iota times sine of n theta. Now, the numerator part is fine. Here you have cosine of a plus I times sine of a raised to the power of 4. But if we look at the denominator, so here we have a sine function and here we have a cosine function. In order to apply the De Moivre's theorem, the real part must be cosine and the imaginary part must be sine. So that means we'll need to simplify the denominator. So let's begin with the denominator portion. So we'll try to simplify it and convert it to cosine theta plus I sine theta form. So here we have sine of b plus iota times cosine of b. So if we take iota as the common factor, so we will have cosine of b plus 1 over iota multiplied to sine of b. Now 1 over iota, this can be also expressed as, in place of 1, we can replace it with I raised to the power of 4 divided by iota. That's because the value of I raised to the power of 4 is 1. This will give us I cube, iota cube. Then again, the value of iota cube is negative I. So iota cube value is negative I. So that means our expression now becomes iota multiplied to cosine of b minus iota times sine b. So we can represent sine b plus iota times cosine b as iota multiplied to cosine of b minus iota times sine b. Now this is raised to the power of 5. Now we are going to raise sine b plus iota times cosine b whole raised to the power of 5. So this becomes equivalent to, so we have iota raised to the power of 5 multiplied to cosine of b minus iota times sine of b whole raised to the power of 5. So iota raised to the power of 5 is simply iota. That's because iota raised to the power of 5 can be also expressed as iota raised to the power of 4 multiplied to iota. And since iota raised to the power of 4 value is 1, so we have 1 multiplied to iota, which is simply iota. Let's leave it aside for the time being. Then we have cosine of b. Now cosine is an even function, so we can also express cosine of b as cosine of negative b. This would mean exactly the same thing. And here we have negative sine b, so we can absorb this negative inside the sine function and write it as positive iota times sine of negative b. So this is because sine is an odd function. So let's write it down. We have sine of negative theta equals to negative sine theta, and cosine of negative theta is positive cosine of theta. That's because our sine is an odd function and cosine is an even function. So this is the fact that we have used here. Now this is done. Now we can apply the De Moivre's theorem. So it means we will have iota multiplied to, so we'll have cosine of positive b plus iota times sine of positive b whole raised to the power of negative 1. So we have used the De Moivre's theorem here. So here n value is negative 1. And this is also raised to the power of positive 5. That means we now have iota multiplied to cosine of b plus iota times sine b whole raised to the power of negative 5. So this is the form of sine of b plus iota times cosine of b whole raised to the power of 5. So this is equivalent to iota times cosine of b plus iota times sine b raised to the power of negative 5. Now we will replace this value instead of this in the denominator. So let's work around. So we had in the numerator cosine of a plus iota times sine of a whole raised to the power of 4, and in the denominator we are given sine of b plus iota times cosine of b whole raised to the power of 5. So the numerator is fine. So we will have cosine of a plus iota times sine of a raised to the power of 4 divided by, so our denominator will be replaced with iota multiplied to cosine of b plus iota times sine b raised to the power of negative 5. So we will take the denominator to the numerator. So there again we have 1 over iota. We have already found out the value of 1 over iota is equals to negative iota. So that means we will now have negative iota. So this will get multiplied to cosine of a plus iota times sine of a whole raised to the power of 4 multiplied to the denominator. So the denominator goes to the numerator. This will become cosine of b plus iota times sine of b whole raised to the power of 5. We need to do further simplification here. Negative iota. So we will absorb the 4 by using de Moivre's theorem. So we will have cosine of 4a plus iota times sine of 4a. So this will get multiplied to cosine of 5b plus iota times sine of 5b. Now we'll multiply these two expressions. So let's do that. So we will have negative iota multiplied to, so cosine of 4a will get multiplied to cosine of 5b. This will give us cosine of 4a times cosine of 5b. Then we have iota sine 4a. This will get multiplied to iota sine 5b, which is going to give us iota squared plus iota squared sine 4a times sine 5b. Fine. Then we'll let cosine of 4a with iota times sine 5b. So we'll have iota multiplied to cosine of 4a times sine 5b. So this will be added to iota multiplied to sine of 4a. So this expression multiplied to cosine of 5b. So we have sine of 4a multiplied to cosine of 5b. Fine. This will give us negative iota multiplied to, so we'll have cosine of 4a times cosine of 5b minus sine of 4a times sine of 5b, because we know that iota squared, this value, that simply equals to negative 1. So this will be one expression plus iota. We can take iota as the common factor. So iota will get multiplied to cosine of 4a times sine of 5b plus sine of 4a times cosine of 5b. Right. That means we now have negative iota multiplied to, so what's cosine of 4a cosine of 5? This is actually an expansion of cosine of 4a plus 5b plus iota times, and this particular expression is an expansion of sine 4a plus 5b. Right. So now we will multiply negative iota to each of the terms. We have negative iota multiplied to cosine of 4a plus 5b minus iota squared times sine of 4a plus 5b. Now because iota squared, that value is negative 1, and we also have a negative sign here, so this will become positive, and this then will become the real part. So we'll finally obtain positive sine 4a plus 5b minus iota times cosine of 4a plus 5b. Thus we can say that whenever we are given cosine of a plus iota times sine of a whole raised to the power of positive 4 divided by sine b plus iota times cosine b raised to the power of 5, so this will become equals to our expression sine of 4a plus 5b minus iota times cosine of 4a plus 5b.